All right, lesson 117 has to do with equations using x squared. We'll do a whole lot more of this in Algebra 1, but so this is just kind of an intro. So when we have something like this, x equals 4, well, that's all x equals. There's only one solution. But when you have an x squared, if you think about it, there's a possibility of two different solutions. If we take the square root of both sides of the equation, we find that x equals 2. Let me erase that other stuff over there. All right, so if we put 2 in for x, 2 squared is 4. But isn't it also possible that x could equal negative 2? What is negative 2 squared? 4. So when you have equations with x squared, it's always possible that you'll have two solutions. Okay, so for example, p squared, the square root of both sides, we would get p equals plus or minus the square root of 16. This is how we write it sometimes, plus or minus. So that means that p equals 4 or negative 4. And you can always check your solutions to make sure that's true. But it doesn't always hold true when we have distances, because we don't talk of negative distances. So when we're looking at the Pythagorean theorem, we don't use a positive and a negative solution. We only use a positive solution. So the Pythagorean theorem has been around since before the Greeks, actually, but Pythagoras got his name put to it. And what it says is that if you square this side, so you kind of see that square in your book. It's a really small picture, but if you square this side, we'll call it A. Okay, A times A, you find the area of the square that comes off of that side of the triangle, and you add to it the area of this square, you will get the area of that square. And so what that means is that we can find the length of a side using that equation. But they won't always give you, so here's the Pythagorean theorem, a squared plus b squared equals c squared. So you could say this is a and this is b, but it doesn't really matter which one is a, which one is b. Okay, because we can reverse them. We can say, well, I want that to be b squared and this to be a squared. That's fine, right? Because addition is commutative and order doesn't matter. So they can be, each leg has an option of being A or B. But what can't change is the hypotenuse, okay? So the hypotenuse is opposite to the right angle. And that's always c squared. So you have to make sure that you're looking at your triangle properly. Always look for the side that's opposite the right angle. So I'm going to do one of these with you. Let's do the first one. It says, given the triangle with the lengths of the sides as shown, use the Pythagorean theorem to find A. So the way that picture is drawn, oops, getting into my next lesson there, is like so. This side is 4, this side is 5, and this side is A. All right, so which side is our hypotenuse? It's the longest side. It's always the longest side, obviously, because these two squares have to add up to be the hypotenuse's square. So we have C. So as I always tell you, start with the formula and then fill in. So we can just leave A as A and say a squared plus 4 squared equals 5 squared. Then we can say a squared plus 16 equals 25. subtract 16 from both sides, and we find out that a squared equals 9. Well, since we're talking a length, when we take the square root of both sides, we're only going to use the positive number. So a equals 3. So that's how you solve those Pythagorean theorem problems. I'm going to let you practice with four Pythagorean theorem problems plus the 2. Lesson 118 and Lesson 119 are all about using 3-unit multipliers. So 118 is about English volume, and 119 is about metric. So it's important. You guys have done a much better job of using unit multipliers. It's still a very important thing to use unit multipliers rather than trying to complete these in your head only. As you recall, we can cancel numbers. When we multiply, we can also cancel units. And so that's what guides and directs us in how to set up these unit multipliers. So we're starting off with 14 cubic feet. If you'll recall, cubic feet are feet times feet times feet. Okay, and we write it out this way to remind ourselves that we need 3 unit multipliers. I'm going to have to squeeze mine in here because I don't have much width. So I know I want to cancel out my feet. That means my inches need to be on top. Remember what a unit multiplier is. It's equivalent measures with differing units. Okay, equivalent measures with 2 different units. We use it in order to convert units. So we need 3 of those because we have 3 feet, and we want to end up with 3 inches because we want cubic inches. Cross them all out. All right, and so our answer would be 14 times 12 times 12 times 12 cubic inches. And we could multiply it out if we wanted, but I'm okay with you guys leaving your answer just like this, but I also want to see this information on your tests. Okay, so metric volume conversions are very similar. The only tricky thing that you guys haven't learned yet is this information right here, and you need to write it down in your notes. I don't believe I put it into your notes this year, which I had a note for myself to do that, so hopefully I did, but if I didn't, it's extremely important that you add this in. One of our practice problems uses this information, and you'll have plenty of problems in your book. Even though it's lesson 119 and you don't have many problems left to do, you want to make sure you understand how to do this because I do believe it may even be covered on a test. So 1 milliliter is the same as 1,000th of a liter. Okay, so if you think of a 2-liter bottle, so 1 liter is half of that, so it's this really skinny bottles, and a milliliter is 1/1000th of a liter. And we use little, baby kind of measuring things to measure a milliliter because it's usually babies that use that for medications and things like that. It's also equal to 1 cubic centimeter. So if you look at the very last practice problem for lesson 119, it says convert 5 million cubic centimeters to milliliters. Okay, well, 1 cubic centimeter is equal to 1 milliliter. So the reality is that 5 million cubic centimeters is going to be equal to, well, that's an S, it's supposed to be a 5. 5 million milliliters. So that's kind of a trick question. But you may be asked to convert it to liters. So you just have to realize, let's say we wanted to convert that to liters. If we had 5 million cubic centimeters, and we wanted to change it to liters, we would say there are 1,000 cubic centimeters in 1 liter. All right, and then we could cross off 3 zeros, so it would equal 5,000 liters. Okay. So let's take a look at, yeah, that's kind of what your very first practice problem is. I'm gonna trust that you guys can figure these out, and we're definitely gonna go over them in our class, but I want to give you guys an opportunity. Okay, here we are at lesson 120, our very last lesson for the semester. There are, as you can see, more chapters after 120, but we really just don't have time to cover them in our class. But that doesn't mean you can't learn the material and enrich your own mind and prepare for your next class. I highly encourage you guys just to go ahead and work through those lessons, and as well as working through some of the appendix information there as well. Okay, so you do need to know these formulas. You're going to have to remember them. So the very first section are formulas for volume, and the second table is formulas for surface area. Okay, so make sure you keep those straight. So volume, we know, is area of the base times height. Okay, and that's true for a pyramid as well, except that because of the slanty sides, it's only 1/3 of that. Because of the slanty sides of a pyramid, the volume is actually 1/3 of what you would expect the regular volume to be. Same with a cone. 1/3 the area of the base times the height. So for the cone, we're talking about the base being the circular part. Okay, so that would be pi r square times the height times 1/3. Okay, so essentially it's the same as a cylinder. It's just that you have all of this area here that you don't need. Okay, so that leaves you with 1/3 of the total volume of a cylinder. Okay, for a cone. And I'm going to actually erase this and rewrite it in the right color so that we're color coded. Oops. 1/3 area of the base. That's not a 3, is it? One-third area of the base times the height. Okay, and the volume of a sphere is an interesting one. It's actually 2/3 times the area of the base times the height. Okay, so if you look down below at your practice problems, directly under the spheres, you will see a sphere there with a radius of 10. So the base is going to be the biggest part of that circle. So what you can think of it as is 2/3 pi r square times the height, which is going to be the diameter. The diameter of the sphere. Okay, we'll definitely do an example of that. All right, now for surface area for a pyramid, the surface area is the area of the base plus the area of the sides. For a cone, surface area is equal to pi times the radius times L. I'll talk about what L is in a minute, plus the area of the base. Okay, so what L is, so this is our cone here. Okay, and L is this slant length right there. That is L. And of course the base is this circle. So they have to give you the radius so that you can find the area of that base. And then the surface area for a sphere is actually 4 pi r squared. So what that's saying is that you could take 4 circles, all of the same size, and cover a sphere. Now, there are a number of really good videos that prove basically why these formulas are true. So if you're curious about it, I encourage you to go look up some videos on the proofs of where these formulas come from. But we're not going to have time to cover all of that in this video, but like I said, there's some interesting videos out there you can look at. Okay, so let's get a couple of these practice problems done, and then I'm going to let you guys finish off the practice problems. Let's look at the very first one. It says the base of a triangular pyramid 4 meters tall is shown on the left. Find the volume of the pyramid shown on the right. Dimensions are in meters. So we're looking for volume. So go back and let's look at our volume of a pyramid. It is 1/3 area of base times height. Okay, so that is equal to 1/3, and they give us our base. Our base is a triangle. Remember, a triangle is 1/2 base times height. So 3 times, wow, I can't hardly see this. That's a 6. 1/2 times 3 times 6. Okay, and then it tells us that the height is 4 meters. Okay, so now we can just start cross-canceling at will. We can cross out our 3's, our 2 becomes a 1, and our 6 becomes a 3. 3 times 4 is 12. So it's going to be 12 cubic meters because remember it said dimensions were in meters, and we know it's cubic because it's volume. The next one, we're going to skip the next one. That's for a cone, but I do want to find the volume of a sphere whose radius is 10 centimeters. Okay, volume again. And so let's start with our equation. 2/3 area of the base times the height. Okay, so it says find the volume of a sphere whose radius is 10 centimeters. R equals 10 centimeters. Okay, so we'll start by writing 2/3 times the area of the base is going to be pi times the radius squared. So pi times 100, I'm just going to do it that way, times height, which is 20. Okay, and so that gives us 4,000 over 3 times pi. And we're doing cubic centimeters. And we can multiply out pi and divide by 3. And if we were to do that, we would find, which I'm not going to spend the time here multiplying that out, y'all can do that on your own, 4,186.7 cubic centimeters. I do want you to work your way through these. I know these tend to be a little bit more challenging, but you do have the formulas right there. And I think you can